There we go. I was trying to get up there to help you come out.
Oh,
How's it going? How did you even get up there?
here, let me show you. You go to the stairs, and
Oh,
here I'm on desktop, so it might be different on VR, but then you get enough of the edge where you can click on the like very top.
oh, me, yeah, maybe VR is different because like I'm trying, but it doesn't let me reach that far.
Oh, yeah, I haven't tried the VR version of Spatial yet. It's definitely very
All right, there's some people here with us. Hello everyone. Can you guys hear me? Hear me well? Hi, Danny. Awesome. I can do that too. Real quick. Um, hey everyone, welcome back. Today's the first time that we're hosting a dive live on a Wednesday. Testing the waters, pun intended. Uh, and welcome back to the Sunken Bloom stage. My name is Matheus Stancaci. For those that don't know me, we do these every week. And dive lives are basically a virtual presentation in a virtual stage where you get to interact with the speaker. We invite a different speaker every week talking about a different topic. Right now, we're actually structuring a series of dive lives, which means that the same topic is going to be bundled throughout a couple of days, a couple of weeks. And the next series that we're actually hosting starting in August is about artificial intelligence. So if you guys are interested in that topic, we're actually having a series of people talking about artificial intelligence in the creative field, meaning creative AI, right? And that goes from this explosion that is happening right now regarding text to image, neural networks that people have been using for inspiration, etc., to people that have been doing way deeper research in terms of creating AI for architecture, design, products, etc. So we have an exciting lineup that is coming on. I'm not going to share everything, but some of these people have been to the stage already. Neil Leach, if you guys have met Neil Leach here on stage, he's an amazing researcher and theorist. And we were super glad, super excited to have Neil Leach back. He definitely inspired a lot of people in the first dive live that he hosted, and I'm sure that now facing this new phase of design where the whole world has access to some tools that help with design and creativity. I know that he's really excited to talk about that. And then some other people like Carlos Navarro, which has been doing amazing research as well in artificial intelligence, 3D GANs. And if you guys know what GANs is, which is basically a neural network that combines and mashes data, right? And 3D GANs, it's basically creating 3D objects based on that. So if you guys have seen Midjourney and DALI 2 and all of these things about typing something and then images show up with something ridiculous like a sofa that is also a crocodile, he has been working on a side of it where he can put in a data set of a lot of facades, for example, and then it generates new facades based on that in actual 3D. So that's super exciting, and we're excited to have him. There's other people in the lineup too, which you guys are gonna have to follow us and follow the series to figure out. And yes, so excited. And then today we have a open conversation type of dive live where we're going to be talking about 3D printing and honestly how to get started and how to, start your journey in 3D printing itself. Right, Kevin just flew away. So before we start, I'm actually going to ask a question and you guys don't be afraid. You are in a virtual space. No one cares. You can answer. Has anyone 3D printed things before? Are you guys familiar with 3D printing? So maybe raise your hands or open up your mic. Anyone has 3D printed before? Can anyone hear Denny? Or am I the only one not hearing her?
I got either.
All right. Danny, we cannot hear you, but I'm sure you were saying something about 3D printing. Can you do like a thumbs up or a thumbs down? It's yes for thumbs up and for a thumbs down if you're using a browser. All right, let's give it up for Danny, guys. All right, she has used 3D printers. Yay. So anyone else has 3D printed before by any chance?
I have a little bit, but it was only like 3 or 4 prints because it wasn't my own 3D printer.
All right, it's pretty good. All right, so basically for the past 3 or 4 years, actually for the past 4 years and a half, I've been using 3D printers for, what started on projects at school, 3D printed models for architecture, which is my background. And I started experimenting. At some point, I joined a robotics lab, which is called the Robotics and Digital Fabrication Lab. And in this lab, we were gifted with a grant a bunch of robotic arms, 3D printers, and so on. And within that, we started exploring the potential of 3D printing, especially robotic 3D printing, which is when you have a robotic arm, depositing materials such as clay or concrete. And then it started the experimentation, right? And so far, I have seen in this very short span such an expansion of 3D printing and how available it is right now, right? For example, back in 2017, 2016, even the labs that we were using, they were filled with Ultimakers or Ultimakers. I think it's called Multimaker. Anyways, which was a monopoly. They held the only 3D printers that were kind of like dominating the market, and it was close to $5,000 a 3D printer. Literally $5K to get a single 3D printer that was pretty crappy, not gonna lie. And then since then, we have seen such an expansion of that. For example, now anyone can get an affordable 3D printer on Amazon Prime that delivers in, tomorrow if you want to, for less than $200, which is stupid, ridiculous in comparison to $5,000 5 years ago. So this expansion allowed for many more people to get involved, many more people to actually start using these things and create a whole network and a community of 3D printing, which I'm going to talk about in a little bit. But this opening for more people to use this tool actually helped the whole market become to terms with it. So for example, right now, if you need something printed, there are people that would have files like that. In this stage, we've had even people such as Danny from 3D Printed Mini Worlds 3D, who have a whole community of people that collaborate in designing stuff for other people to print, or Caleb, right, from the Controller Project, that is also working on this field where people introduce their own models and then everyone can download. And that is the beauty of the 3D printing community, which is collaboration in a way. We see a lot of collaboration all the time. So that's pretty exciting. And then since this robotic academy, the robotic lab that, thank you, Danny, the robotic lab projects that we were doing, I started posting content about 3D printing, right? The little projects that I was doing and the little 3D models. Out of curiosity, I started experimenting with even like puzzles or little things during the pandemic to keep, the motivation on. And then through social media, a lot of questions rose from people that were watching, right? So what 3D printer should I get? What type of materials should I use? How to get started, basically the bottom line. So then we thought about having this conversation on the Untitled stage to kind of introduce a couple of first steps and have this open communication, open conversation about this. So, all right. So now that we got a couple of responses and we know more or less who has been doing what, who has used 3D printers before or not, if anyone is starting with 3D printing, right, and you want to get one, right, my first tip would always be ask if someone has a 3D printer and test theirs, right? The thing is, if you're doing something very specific or a very specific type of printing, you want to know if the printer has the possibilities, etc. So if you do have someone in your circle that has a 3D printer, ask them and kind of like test them out before you do anything. But if you want to start from scratch and you want to get started, just like do it, get one and start. There are two 3D printers that I always recommend, and I wear their shirt like to tell the world about them, which are the Prusas and the Flashforge. So if you guys want to take a look, I have here two 3D scans of those two machines, and those two companies are, absolutely fantastic. So first, I'll start with the Flashforge. right? So this right here, this big boxy red thing, that was actually the first 3D printer that I've ever gotten. This is a 3D scan, so the quality is not the best, but it's here to paint a picture of it, and has been 3D scanned using Polycam, which is a free app. We're not sponsored by them yet, but if you guys are interested in 3D scanning. So the Flashforge Finder, this machine, is a very, very simple to use. And when I say that it's simple to use, it comes already assembled. The entire thing comes in a box exactly like this. You have to plug it in, and then you have to just follow the prompts on the screen, which take 5 minutes, and then it's printing. In terms of, okay, yeah, I hear dogs. In terms of affordability and all, this is one of the cheapest printers you find for this type of quality. And I think on Amazon or something right now, it's about $200 for this printer. However, in terms of quality and how much you can count on it, it's pretty much never failed me, right? And it's the type of printer that can get you a long way to start prototyping, start using them. The only downside, if there is one, is the bed size. And whenever you get a 3D printer, there's always a few things that you have to look for. And the main component that you have to look is the bed size. So if you look here, this blue portion, that is what the bed is. And that's the surface where the 3D print actually gets printed on. So the volume of the printer is huge. All of the structure, this black part, with the mechanisms for it to go around. But then the bed size is 5.5 by 5.5 inches, which is pretty tiny. It's less than your hand spread out. So in the end, you can only print small things or partition the model into many parts and print multiple times. However, it's so reliable that one time I was doing a project with a friend who had a Creality, which is another brand, and I had this model. So he had a bigger machine. So we were doing the same model. So basically I had to splice mine into many smaller ones, and it would be a much longer process. You could just print the whole thing. And his machine failed so many times that one tiny machine, beat the big one, because in the end, the Creality was having all those issues. And don't get me wrong, there's a lot of people that love Crealities and their team Creality all the way. But my personal experiences with them has only been negative. So I cannot personally recommend Crealities, which are the most common and most accessible printers in the market. But if anyone has any good experiences with Crealities, like let me know. I would love to hear a good story from a Creality user. Anyone has used Crealities before? All right, so you guys are on my team. Let's go. Uh, so that's it for Flashforge, right? Which is the simplest, the easiest to use straight out of the box. And then the second one, which is actually my first recommendation, are Prusas. Prusas are, in my opinion, the best affordable 3D printers in the market right now and the most reliable. This is a 3D scan of the Prusa Mini, which prints 7 inches by 7 inches by 7 inches, which is already much bigger than the Flashforge. And the overall size of it is still smaller than the Flashforge. So the bed is larger, but the footprint of the 3D printer is much smaller. And the cool thing about this is, if you can see, like, it's actually cantilevered, which it terrified me at first, because if you actually bend this, you ruin the printer, but it's remarkably strong. I've transported this across continents, actually, my luggage, and it still prints amazingly. So Prusas, they are made by Joseph Prusa, and they have a huge culture around them. It's ridiculous. If you guys do end up getting a Prusa Mini, you see even the manual, right? When you're flipping through the manual, one of the steps is to open the bag of gummy bears that they send in the box, and you have to place the gummy bears on the bed. And then after a couple of steps, it asks you to eat some of the gummy bears. It's just a a joke, but it gives you that feeling of being part of a culture. And their support system is absolutely fantastic. I had problems before that I called them and they were able to help me right on the phone real quick, ship me a piece. That in the end was my fault. Like I broke a piece because I was trying to remove a screw, but then they sent me the new piece for nothing, which is pretty cool. And then one other thing about the Prusa Mini is that it is affordable, compared to the professional ones, right? So we're looking at here at around $400 for the Prusa Mini, and then the Mark III, which is a model bigger than this, is around $800, and it's slightly larger. Actually, it's like an inch larger. It's instead of 7 by 7 by 7, it's 8 by 8 by 9, I believe. Which does make a difference if you're printing like large volumetric stuff, but at the same time, Prusa Mini starter, that's the way to go. Does anyone have any questions or comments at all?
This one does need assembly.
So that's a good question. And the answer is kind of. The Prusa Mini comes pre-assembled, and that's the parts that make them. So for example, if we look here, I love that I was about to 3D model this because I couldn't find a model, and then I was like, let me just scan, and this is so much better. So you see, for example, this is the motor that brings the Z-axis up and down, and it has all of these screws, and it's connected to the tower. All of this is assembled, right? So all of this part that I'm showing here, as well as the extruder on the track, all of this comes together. And then the bed, this is magnetic, right? So after you're done with the print, you can remove, bend, and the print is out of the way. This is all connected as well. What you have to assemble is this tower connected to the base, which is pretty simple. You have to attach this panel and connect the wires in the back. And the instructions are so simple, anyone can really do. And they're fun, right? I talked about the gummy bears. It's a fun process. It takes about 25 to 30 minutes to put a Prusa Mini together. So it does take 30 minutes more than the Flashforge, but at the same time, this is also the best quality you can find under like $2,000, in my opinion. And this is like way cheaper than $2,000. So it's a good metric to show there. Is anyone familiar with IKEA? The furniture company? Their instructions are pretty much like an IKEA furniture. It's simple to use. Anyone can look at the drawings and figure out what goes where. And yeah. So I was showing a couple of things. I was talking about a couple of things regarding culture and 3D models, etc. So let's say getting a 3D printer, right? The usage of it, it really depends on what you would like to do, right? If you're a designer and you design your own pieces, chances are that you are modeling for 3D printing, which opens a whole category of designing for 3D printing. You have to keep, the meshes clean and have them like, optimized in a certain way, as well as keeping distances, if the distance is too small, it's going to connect. So tolerance, things like that, right? One project that we worked on, which was called the gear door, we designed and 3D printed gears that you could attach to your door and change the way you open a door handle. So that was actually a big study on the tolerances that you need and the whole 3D printing process for a product like that is completely mechanical, right? You're able to step on a pedal and all the gears rotate and open your door handle. And we had to prototype all of the tolerances. And we're talking about fractions of a millimeter, like 0.1 millimeter makes a whole difference on how the piece fits with the other, etc. If you guys are on, TikTok and whatever, you ever fell into the rabbit hole of 3D printing, what's it called, time lapses? Yeah, like those people that work on those super glamorous containers, right, that you kind of put the top and it slides in, that's a very precise type of printing and designing for the machine. And then even changing the material might change the need for the tolerance. However, if you don't design, or if you want to print stuff that is not even designed, there are whole communities and websites and platforms that are made for 3D printers to download and print stuff. One of them, and I'm just going to stand here next to Danny's model, but by the way, this is a model of the Parthenon in Greece by the Mini World 3D. One of those websites that I was talking to is called Thingiverse. I'm not sure if anyone has ever heard or used Thingiverse, but it's this free website that you can just go in and type anything, and chances are someone has made a model in there. There's all sorts of things from, a cow napkin holder to gaming swords and cosplaying outfits, stuff for the house, like tools for the kitchen, holders for glasses, anything, which is pretty cool. And it's kind of this social media where people design their own stuff, they post it there, and then they get likes on the models that they do. People comment and, leave impressions. They post pictures of the stuff that they printed from someone else. And you can also tip the designer, right? So let's say I really like this, I don't know, headphone holder that I put on my desk, and you can actually tip them, but most of the models are free. And it's not one of those websites that there's a couple of free stuff and everything else that is valuable is paid. No, like there, anything you can find it for free, which is pretty sweet. There are other websites as well. There's, well, of course, if you guys are into 3D modeling and all, you probably know CG Trader, Turbo Squid, all of those websites also have 3D printing, 3D printable objects, but at the same time, they have a lot of paid stuff as well. And if you guys know any other websites, that are interesting for 3D printing, let me know and you can bring it to the table. Oh, Prusa. Prusa actually in their website has a lot of 3D prints. But if you think about the community of Prusa versus the community of the whole world that uses 3D printers, the library that I've found in Prusa, it's pretty good. There's really good stuff, but it's not as vast as something like Thingiverse. And yeah, with that, you can do anything. And that's the beauty of 3D printing, right? Because instead of going to the store, if you need a specific thing that could be 3D printer, you could you can design it, or two, find a model that is already designed, and instead of waiting days for your purchase to arrive, you actually can print it. And of course, we cannot do this for like, oh, if I need cleaning products, I cannot 3D print cleaning products yet. But, a lot of stuff that we do need in a day-to-day, you can find replacements. If your cabinet drawer breaks and you need this one attachment, you can probably 3D print it. One time, I bought a kid's pool with my roommates and we made a hole in it. So I 3D printed a patch that would go in the hole and stop the water from coming out. That's the type of stuff that you can do, as well as bring your creations to life. If you design something, you can prototype it real quick, figure out the right sizes before production. And back in the day, we couldn't, right? We had to prototype with a company that prototypes, and after months, you receive the first piece. If there's an issue, you have to fix it, prototype it again, and that is like months and months and months of a project, which you can replace with a machine that costs $400 that you can have in your desktop and get it done real quick. All right, so regarding, yes, someone was saying something? Hello? All right. So regarding the different materials, right, what the 3D printer does, and we're talking about FDM, which is fusion deposition modeling. So this type of 3D printers uses a specific material, which is typically a type of plastic, and then it melts and deposits it in a layer and slowly goes up building the model. So there's so many different types of materials that you can use. It's pretty incredible. There's a whole library you can choose from. The most common being PLA. And if you guys are lost I'm here by the material wall. I spend way too much time baking this material wall, so you guys better to look at it. So there's the PLA, which is the most common and the easiest to use. Melting points, etc. It's pretty easy. There's no much rules to printing PLA, and you can find this anywhere, right? It's the cheapest filament. A spool of PLA costs about like $20, I would say, and it lasts a really long time, like lots of prints. Then we have ABS, which is another type of plastic in this sense, and ABS is way softer than PLA. So if you want to print something that looks really smooth, one technique is to print with ABS and then bathe the model in a vaporized acetone. So literally acetone, which is nail polish remover, you can put it in a bucket with acetone soaked cloth around it, and it will corrode the model enough so it looks like a very smooth surface. We also have flexible filament, and even people that are 3D printing shoes and prototyping shoes or something that is a little bit squishy have used flexible material. My recommendation is do a little bit of research before using this, because this can clog your 3D printer, if you're just testing it out, not changing the temperatures and stuff. But flexible material is super interesting. Even if you're designing, let's say, the rubber feet of a chair or something, this can go a long way. We also have carbon fiber. And by the way, these colors are just for the aesthetics of this. They don't correspond to the color of the filament, especially because all of these can be pretty much any color. Even the carbon fiber, I've seen carbon fiber filament that is like blue. So carbon fiber, a lot of people have been using this to print really strong mechanical pieces or slender, furniture that has a lot more strength to it. It is more on the costly side of 3D printer filament. So let's say if a spool of PLA, 1 kilogram, is about $20, we're looking at carbon fiber at around $50, sometimes for half a kilogram. So, it makes a big difference. It's almost more than 4 times the price sometimes. And then this one, it really depends. Quality really depends. For PLA, yes, quality matters, but even the shittiest PLA can do something. But carbon fiber, I found really hard to use bad quality ones. We also have a magical filament, which is water soluble. So water soluble filament, it disappears in water, right? So you can put this in warm water for, 20 hours, let's say, or overnight, and it will simply disappear, dissolve, etc. This is amazing if you're doing molds. Hear me out. If you 3D print a mold for casting something, you have to 3D print the positive, and then you pour silicone or something to make an actual mold, and then you remove the 3D print, and then you can pour concrete, right, to make a concrete product. Now, with this type of filament, if the model is really complex, you can't really make a mold of anything, right? Let's say there's a bunch of holes and intricate parts to it. It's kind of impossible to make a mold that is not complex. But now imagine that you can 3D print the mold as complex as it is, because the 3D printer can do mainly anything, or pretty much, right, virtually anything. And then you pour the concrete in the 3D print, and then you just dump it in water, because after a couple of hours, the filament will dissolve, and now you have this impossible concrete piece, right? The possibilities here are endless, and I don't know why not a lot of people talk about the potential of using this, but it's pretty cool. And I can show some tests one day that we've been doing. This is also a little bit expensive. It's not as expensive as like carbon fiber or something, but we're looking at like $40 for 1 kilogram, which you can go a long way. You can print a lot of things. But then if you buy one of these, don't do it like I did and keep it outside of a bag, because the moisture in the air slowly corrodes the filament, even though it's not in water. So yeah, treat your filament. And then the final one that I have on the wall of filament is conductive filament. And this is pretty cool if you guys are into robotics and coding and wiring. This is actual filament that conducts electricity just like a wire, right? And you might be wondering, oh, what can I do with this? You know, what's the point? You can build a whole computer or network that is an actual design piece, right? Hear me out. If you look at an Arduino or a microcomputer, microcontroller, whatever it is, it's made of electrical components. There's a motherboard, so circuits where electricity flows through, and it calculates things, right? There's switches, there's this and that. Now, imagine you're holding an object that is made of different pieces, and all of those are technically the wires, and that's me like quotation. It's technically the wires, but it is also the design. So now you have a computer piece, you know, which I think it's mind blowing. I get excited over this type of stuff. This part of like product design that has a different type of functionality than it intends or it looks like. And this is something you can do with conductive filament. There's a lot of research and a lot of tests, of course, that if you know anything about computers and resistors, right, the thicker you have the resistor, the more resistance you have. So you have to experiment, but that's something you can use to your advantage, right? Let's say you're doing a lamp where the base is designed to conduct the electricity off the lights itself. The different thicknesses of the base itself can control the power that the lamp receives. So these are all interesting concepts that are possible with 3D printing and experimenting with material. And there's many more types of filament, like many more different types of filament that dissolve in different solutions, like citrusy stuff, but it will make your pieces smell like oranges forever. There's ASA, which is way more UV resistant. So if you're printing something that is going to stay under the sun for days and days and days, like let's say a tent cap, right, for you to assemble a pavilion in the air outside. You probably want to print with ASA because it's so UV resistant that it's not going to crack over time in the weather, and so on. There's millions of them. There's millions of boards online or charts that you can find different specs and different things. But nonetheless, I wanted to bring some of them and talk through a couple. And then once you do get started with 3D printing, you know, anything that your mind can think and produce can be achieved, right? Some models are going to be too hard to print and you're going to need a lot of supports. And some stuff you start to design already thinking about the 3D printing portion of it and the manufacturing. And this is an example, which is the shell lamp designed by Serendipity Furniture, which is a part of Sunken Blimp. And this is a piece that is designed for the printing. So this particular product, right, is both a physical and a digital product. So in this case, when you get one of these lamps, you receive the physical lamp and you receive the digital one that uses an NFT to decorate virtual spaces. So this right here is one of these NFTs. So I just brought one of the NFTs here, which you can use even as a pavilion if you want to. All right. So regarding the physical lamp itself, right, it's designed for 3D printing, so we don't need any supports to print this. That is the cool stuff. All of these holes that you see are calculated so the cantilever of the 3D printing works just fine. Because if you think about the 3D printer, what it's doing, it's melting plastic and adding layer by layer by layer by layer. So if you're trying to print something that is horizontal, right, printing, it's going to start printing in the air and there's nothing underneath to hold it. So all of these, they have a slight angle that is just enough so the layer height holds itself up all the time. So we can print this without any supports. It's kind of like a push and print type of product. There's not much post-production after printing. And yeah, this is the type of stuff that you can do and experiment as you go. And if you do have a 3D printer and you want to test how well your 3D printer prints in an angle, there's many of models that you can download for free and print that have different angles, and then it annotates there. So let's say the angle on 70, 80, and like 60, 70, and 80, they failed, right? It printed in the air and printed nothing. Now you know up to what level you can push your 3D printer. And then you can use that data to, design to push the limits, right? All right. Does anyone have any questions or anything they would like to know about 3D printing?
What if you're not a designer and you just downloaded something from Thingiverse or something? How do you get started? What do you need to know? What's the basic knowledge you need to start 3D printing?
That's a good question, and it pretty much depends, right? But I truly believe that even if you're not a designer, the websites that I was mentioning, like Thingiverse and all that you can download models, they are all pretty much ready to go, right? So you can get a 3D printer and just download models from those websites and print stuff that was already made. And there's so many things, like I kid you not, like there's tabs and categories and pages that go for ages. So I do think, for example, if you would like to get a 3D printer and use for that purpose, the first thing, check out Thingiverse. See if the type of stuff that is there is the type of stuff that you would actually use and print. And if that makes sense, and if you think, oh, that's actually going to save me a lot of time because I would buy this, I would buy that, and then you can make it. Now you can make this calculation of like, okay, I'm investing in getting a 3D printer, so I can save the amount of times that I need to go to the store. I can save the amount of times that, I need to get a gift. Maybe you can gift people or 3D print your own Christmas ornaments instead of buying them. This is the type of stuff that is pretty interesting, and you don't need to be a designer to 3D print cool stuff. And then if you do want to see more 3D printers and their specs and the prices and all, there's a lot of YouTube videos as well that rate them. They actually print tests and go through each of the specific things that I would recommend. But my personal opinion for anyone that asks me, I would say a Prusa Mini or a Flashforge for sure.
Thank you much.
Yeah, of course.
With all the materials that you described on this material wall, do you have to have specific kinds of 3D printers to be able to print with like carbon fiber, or can you do that on the
Yes. So all of these are pretty much common. I've never had any issues with any of them, and basically I have I have tested pretty much all of these materials on both printers. And the only thing is each type of material is going to come with a specification on temperature, and you can find also online the recommendations for the speed of printing or something. Clay usually prints at 215 Celsius, but then you look at ABS, usually you want to print it at a higher temperature, like 230, and keep the printer enclosed. So in the case of those printers right there, the Flashforge doesn't have a heated bed, right? The bed is cold. It does not heat up. So ABS prefers a heated bed. Otherwise, you have a lot of shrinking or, it starts bending due to the cold. So you can print ABS in something like this, but, the material itself behaves better in a different environment. So the Prusa Mini, it actually heats up the bed. So you can heat it up to 60 degrees, 70, 80 degrees Celsius, and then the print comes out better. Now, the actual machine is not enclosed, right? So everything you're printing, if there's wind going through, it's going to cool down the print. You can easily put up a box on top just to stop the wind, and then you can print something like ABS. So that would be the only, I'll say, restrictions regarding materials. It's actually the properties, but the machine itself can print them as long as it can reach the temperature that it goes to. And regarding Prusa Mini, it can go up to 280 Celsius, which I've never seen any material that needs 280 Celsius. Everything is like within range of what the Prusas can do.
Oh, okay. Awesome. Thank you.
Of course. Any more questions?
Hey, hello, Mateus.
Hello.
Hello.
I have a question. What's the best design software to design a 3D object?
Yeah, of course.
Yeah, of
So,
course.
can you mute yourself? Because I can hear you. Yeah, awesome. So it depends on what software you use, right? Because if you the good thing about 3D printing is that whatever you can do, you can bring it to reality. So each printer kind of has its own software for slicing, which is the term used for converting a 3D shape into the G code. And the G code is what the machine reads, right? Which is the position in each layer that it needs to be in order to make the object. So for example, I can design this piece that we see here on the bed, which is half of a pulley system in Rhinoceros, or I could have designed in Blender, or I could have designed in SketchUp. It doesn't matter, right? Then it automatically calculates each layer where the machine needs to be to make the object real. So if you are better at working SketchUp, I would recommend learning how to make models better in SketchUp for 3D printing. If you do like using Rhinoceros, I recommend learning how to export stuff for Rhinoceros for 3D printing. It really caters to what you do, and I think that's like the best advice. However, I have personally been using a lot of Rhino forever, regarding 3D printing, and that's the place where I find the most resources and tools where I can real quick like detail the tolerances, for example. So if I want to make a piece that has exactly 0.05 millimeters one between the other, because then when I put it, it's going to slide or go through, or 0.15 millimeters, whatever. I can do that in Rhino to the precision that I could never do in Blender, right? So in Blender, it's much harder to work with dimensions, but if you want to make a blob, or something really, that where dimensions don't really matter, then I recommend using Blender. So it kind of goes by project by project. For architecture stuff, you can even print something that comes from Revit, right? And there are tools such as makeprintable.com. If you guys don't know, this is a website where you can load in an STL model, even if it's completely fucked. The model has holes and surfaces that don't have thicknesses and all, and it calculates what it needs to fix in order to 3D print well. So you can dump in like monsters of a file that are really, really bad, and it calculates for you. There is a monthly fee. I think it's like $2 or $3 if you're a student, to be able to use it more than twice a month. But it's definitely recommendable for people that are not, let's say you don't want to invest your time into completely redoing the project for a client, but you want to make a model. Instead of putting, 5 architects to figure out how to 3D print, you can get the software for $3 a month and then run that model through. It makes a model that you can print and show a client, a model straight from Revit. Well, Revit, makeprintable.com, then printing.
Amazing, thank you.
Of course. All right, guys. I think that's it regarding this like introduction kind of conversation. If you guys are interested in more stuff regarding 3D printing, please join Discord, join our community. There we have many different channels. You can ask any questions, you can share stuff, you can show your own work, and we talk about it. If you have any questions or help, what material should I buy, what company, etc. This was an overview, but we can talk into more details, and we're always open for conversations there. So right at the bottom of those stairs, we have a QR code with a nifty link to access Discord. So if you guys are interested, definitely check it out, and I'll see you guys there. Thank you. Thank you. All right, everyone. So have a beautiful Wednesday. I'm used to saying beautiful Friday. So have a good one, and I'll see you guys next week for the very final 3D printing dive live with Prash, who's going to show us some pretty cool time lapses. He's been blowing up on TikTok. You guys are going to like that. All right. Have a good one, and I'll see you guys soon.